It will carry that you want R1 to be your server. And you want to use the address 1.1. You send it as a broadcast on behalf of. Both devices can receive. Then device 1 knows to use its address. It will give you an ACK. Make a response to this message. And is locally documented. Why send it to this device? Because it is broadcast. So R2 can also receive. R2 received and found that the choice is R1. It takes back the allocated address. For other clients in the future. This broadcast message not only told the server you want to choose. Let the server you don't want to choose know that you are not selected. So this is a very optimized mechanism. Sending a broadcast is equivalent to telling everyone. To us. Here is a bogus DHCP attack. When you reach the NP stage in the future, you will learn DHCP snooping. Then you will solve it. For example, some devices are privately connected to the network. Privately entered a DHCP server. Or privately came in a TP-Link. Because TP-Link opens some DHCP functions by default. If the TP-Link is privately connected in the internet, it may cause your device to be unable to connect to the internet now. When you send a message, maybe it replied to you first. We didn't say who it would choose. This is very simple. It receives the message from who sent it first. Whoever it chooses. Device 1 first sends it. It selects device 1. Device 2 first sends it. It selects device 2. Finally, the client sends a confirmation to it. Then this address is used for it. The local will remember which MAC this address is used for. After that, it will not redistribute this address to other devices. Here are some conceptual parts. Let's look at the configuration next. The configuration is also very simple. Throughout the NA phase, many things are actually a basic understanding. So it's not hard to configure something. We first turn on these devices. Some students may ask, under what circumstances will the client reject the offer? The client has a release address. You can release it manually. But it won't refuse. Because this service is initiated by it. Suppose it now initiates a message. Want an address. The device gives it an address. Then it refuses. This situation does not exist. Only two cases. One is that it is going offline. The second is that it wants to configure manually. Then it will actively send messages to the device. Release the address allocated by the device. It will not take the initiative to reject the offer. If it now receives two messages at the same time, then it will choose the first, not the second. Because there is no need. Unless there is an artificial configuration. It doesn't want to use DHCP anymore. It will release this address. Okay. Let's configure these PCs. The switch does not need to be configured. Open this router first. What we use today is a global allocation of DHCP. The allocation we are talking about today is also a commonly used one in DHCP. How should it be defined? I want to treat this device as a server. The device below is the client. The client asks the server to get the address. First of all, we need to define an address pool here in server. In this lesson, the PC does not need to configure IP, mask and gateway. Let's look directly at R1. VPCS is virtual PC. First come in R1. We first configure the address for the interface. E00 interface. Suppose the IP address is 192.168.10.254. This is an interface address. Next configure the mask. 3255 and 10. No shutdown. Now that I want to use R1 as a DHCP server, then I must define the address pool. IP DHCP pool. You can see. Followed by name. We can name it. Call it P1. I now define the name of an address pool. Certainly. In the future, if you assign based on different departments, when you reach the NP stage, you will learn DHCP relay. Then when we go to define the name, you can write pool RAN D, pool technology, pool finance, etc. It's all okay. Write a P1 now. Just know it. I now want to define the assigned network segment. That is, now these devices have to find R1 to get the address. Which network segment is the address that R1 wants to assign to the device? It has to define. For example, I now define a network segment. Type network. Then enter a question mark. Now you can go and specify a network segment. For example, 192.168.10.0 network segment. 24-bit mask. It's okay to write like this, because the network itself is connected to 10 network segments. I will write it as 10 network segments for you. After assigning the address to the device. After the device gets the address, it can directly connect to the interface of R1. R1 is in the 10.0 network segment. The device asks it for an address. R1 assigns the address of the 10.0 network segment to the device. Then the device can directly find R1 in the future. So usually we deploy this device of this DHCP server. It can also act as a gateway. This is the deployment logic for the device. For us now, when the future PC is looking for it to get the address. In Cisco, it is assigned from small to large. That is, PC1 will get 10.1. PC2 will get 10.2. Then after I configure the network segment, I want to set the default gateway. The default gateway is usually set to itself. 192.168.10.254. Then we go to specify the DNS server. Suppose we configure 4.8. After configuration, let's take a look at our configuration just now. Do show run. IP DHCP pool. Let's look at the configuration of the DHCP pool now. We first define a network segment is 10.0. After specifying the gateway is 10.254. Then configure the DHCP server to be 4.8. Okay. We are now done configuring. After the configuration is complete, the host can be dynamically obtained. This operation is very simple. IP DHCP. This is PC3. You see there is a DORA in front of it. This string of characters represents these. It happens to be the first letter of the message. The first, D, stands for DHCP. The second, D, stands for discover. O, stands for offer. R stands for request. A, stands for ACK. Here are the first 4 messages. Represents that it has now gone through several processes. Then got a 10.1 address. Gateway is 10.254. We can view some detailed parameters. Show IP. You can see. Here DNS is 4.8. The network segment is 10.1. The mask is 24 bits. Gateway is 10.254. This is 4.8. DHCP server is also 10.254. This is a normal way to get the address. Let's talk about another way now. You will find, in a business, a lot of things are online now. For example, the picture here is a PC. But it could be some other device. It can be a printer. First of all, you need to know Now this PC may go offline and shut down someday.